Okay, so today we're going to introduce a new number set. Last we've been dealing with integer rules. Now we're going to add the rational numbers. So let's first define what makes something rational. We're going to define the variable q to mean the set of all numbers that look like a over b where or such that a and b are integers themselves. And we're going to throw in this little stipulation that b is not 0. Okay. So basically anytime we're dealing with fractions. Okay. And inside the rational number a over b, we call a numerator, and we call b a denominator. Okay, so we're going to look at some of the different guidelines and rules that dictate fractions and what that might represent. Starting with some different ways that we can represent these things. So an area model of a fraction means I can take a whole object and I can slice it into a certain number of even pieces. So here I've got a bar that I've cut up into 3 slices, and if I shade in one region, I have 1 out of 3 that I've shaded up. Or similarly, if I look at a number line, so I say here's 0 to 1, and I split that up, and I shade in, say, 2 parts of the 3, then that would be represented by 2/3. Or, again, using sets. So I can look at a group of, say, 5 objects, and of these 5 objects, I can shade in, say, 3 of them, and then that would represent the fraction 3 out of 5, or 3/5. Okay, so what exactly then, or what are some other things that we could use to consider being fractions? Okay, strangely enough, students are exposed to fractions a lot earlier than they understand the formal notation behind what makes a fraction a fraction. They learn about things like 1/2 of a pizza or 1/4 of a cake. They hear these expressions and it actually has meaning to them. So when we start to transition to the formal language of a fraction, we want to take advantage of things that they've already been exposed to. So we want to consider that to really understand what a fraction means, we start off with, a over b, or there's 2 numbers, one on top of each other, and we want to consider that that b is the whole, not HOLE, but WHOLE, is the whole part that we're being considered. So when you look at pizza, how many total pizza slices are there? Then we want to talk about how many equal parts we've divided the whole up into. So we want to ask the class, so if I have a whole pizza and I slice it up into 8 pieces, how many same size pieces are there? And that'd be the 8. I'm sorry, I didn't mean 8, I meant b. Sorry. In the fraction, we consider the number of slices that we've divided something up into. That would be the denominator of the fraction. And then the number of parts that we select would be the numerator, or a. Okay, so again, students have a much stronger understanding of fractions well before they get the formal language on it. They understand in a basic sense what fraction means, and we just have to take advantage of that previous knowledge. In dealing with fractions, we also want to talk about a proper versus an improper fraction. So just as a reminder, in looking at any fraction a over b, if a is less than b, we consider that to be proper, whereas the numerator is smaller than the denominator. If a is greater than b, then we call that an improper fraction, meaning if the numerator is larger. Okay, so something like 2/3 versus 3/2. 2/3, the 2 is bigger than the 3, it's in the numerator, so we call it a proper fraction. And in the other example, 3 over 2, 3 is bigger, so it's got to be an improper fraction. Okay, in the number line model, so we need to start off with a number line, so let me pause that real quick and then we'll look at what a number line is. Okay, so when we talk about dividing a number line up, we have to start with how many pieces do we want to divide this up into, and then what would we name them. So let's say I want to divide up into fourths. Okay, so that means inside between 0 and 1, I've got 4 equal chunks. Inside between 1 and 2, I've got 4 equal, same thing between -1 and 0. And what would we name these things? Well, 0, we'd say 0/4, that's 1/4. That's 2/4, 3/4. And then we'd ask, well, what would 1 be equivalent to? So that should be 4 over 4. And then we can just keep the pattern going. So if I add another fourth, I get 5/4, and then 6/4, and then 7/4, and then 8/4. And I can tie into students. I'm like, well, what do you notice? What is 8/4? What's so special about 8/4 in the number 2? And hopefully someone can raise their hand and go, oh, wait, 8 divided by 4 happens to be 2. Go, so there's a connection between fractions and division. Interesting. And then you can tie in that you also have negative elements to this. So you can go backwards and also make those same general connections. You know, what's -4 divided by 4? Ah, -1. Aha. So what our fractions seem to be doing with as far as number lines go? Well, it seems like we're dividing and we're simplifying it down, and that's a great connection to make. Okay, so then using either the number line model or the area model or the other models that we've looked at, you can then develop this idea of equivalent or equal fractions. You know, we can say something like, let's take a look at 1/3 and 2/6. So if I take an object, hopefully they're going to be the same object, and I divide it up into thirds, right? And I look at that middle piece. Oops. Divide this up into 6s, so all those pieces I'm going to slice up. And I could say, well, if I go thirds, or if I go 2 out of 6s, so 1, 2, 3, divide that up, what do you notice about the area that's being represented? And hopefully students will make the connection, oh, it's the same area. So if the areas are the same, what does that suggest about the fractions? That means the fractions have to be equal. So that there's other ways that we could write the same number with different forms. And then we would introduce this idea of what's called the fundamental law of fractions, that if a over b, if I've got one fraction, I can multiply the numerator and denominator by the same number and generate an equivalent fraction. So I could come back up here and I could say, well, what do we multiply 1/3 by to get 2 out of 2/6? And realize that we're multiplying by 2 over 2. And then we can tie in, what happens if I go backwards and start off with 2 over 6 and end up with 1/3, and that's reducing. So we can make those nice, lovely connections for students. And then that also brings into simplifying fractions. So once we've sort of developed, you've got equivalent forms, and that you can go one form back to another, then you can define that verb to be simplifying. So let's take a look at, say, something like 6 over 21. We would think about, well, what numbers break up to give us 6? 2 times 3, and 21 would be 7 times 3. And I'd ask, well, what do you notice? They both have 3's in them, so I can divide that out. And that leaves me with 2/7. So what does that mean about 6 over 21 and 2/7? They are equivalent to each other. They have the same area, and one simplifies down or reduces down to another. Okay, so let's kind of practice doing some simplifying with some more R-style math. Let's put some algebra in this and just practice what we would simplify that down to. So 28ab squared over 42a squared b squared. Let's look at that one. Let's do a plus b quantity squared over 3a plus 3b. And let's do one more. Let's do a squared minus b squared all over a minus b. Okay, so you're welcome to pause the video and kind of try it for yourself, or we'll kind of work it together. Okay, so 28, we're going to look at as what kind of common factors can we break it up into. So 28, I can do 2 times 14, and 14 is 2 times 7, and that's a times b times b. 42, we could break up into 2 times 21, and 21 is 3 times 7, and a squared is a times a, and b squared is b times b. Well, what do I notice divides out? I notice that the 2's divide out, the 7's, I got an a, and both b's divide out. And what are we left with? We're left with 2 over 3a. So that would reduce down to that. In the second example, we got a plus b squared. Okay, so that really means a plus b times a plus b. And I can factor out a 3 from the denominator, so 3 times a plus b. And hopefully we notice that one of them divides out. And we're left with a over b over 3. So that's what that simplifies down to. And in this last example, hopefully we recognize difference of two squares. So a minus b times a plus b over a minus b. A minus b's divide out, and we're left with the expression a plus b. So hopefully that was a little bit of a quick practice for you.